And welcome everybody to the Daily Space Weather. We've got coronal mass ejection warnings and solar flare warnings persisting, no less than 6 sunspot groups, and lots more to cover, including chaotic electron belts and, yeah, lots of things. Here's a new sunspot rising in the southeast, which makes for, like I said, 6 sunspot groups. They're all pretty significant. So major solar uptick here. Again, coronal mass ejection warning still in effect. Solar flare watch still in effect. Don't get the two confused. Solar flares are photons. Coronal mass ejections are protons. Here's the northwesterly sunspot group. It's got a huge plage behind it. And you can see the umbra here. This is composite imagery, by the way. This is 1700 and 171 angstroms from the Solar Dynamics Observatory. Just spectacular. Here's this setting spot in the southwest. You can see some activity from that. And the most majorly active region is in the south-central portion of the sun. 3 large sunspots here. Well, 2 large ones and a small one. Moving into the Earth-facing quiet zone here. So the likelihood of these producing major flares is a little bit lower here while they're facing the Earth. And as they move toward the western limb, they will grow more and more likely to produce major flares. Crazy levels of activity and some spectacular imagery here on the channel. Let's take a look at Lagrange point 5, where stereo A is located, as we've got a coronal mass ejection headed Earth's way. And it looks like NOAA is not forecasting it correctly once again. So the last one, the last 2 coronal mass ejections were forecasted to strike Earth. They were barely even detectable in the solar wind data. This one not showing up as Earth-directed in their Enlil simulation. This one I do believe to be Earth-facing. It's still pretty minor because it's not really that big of a coronal mass ejection. It's fairly diffuse, and a lot of the plasma stayed in the corona. This is the stereo A coronagraph on the left. This is the coronagraph difference imagery on the right. And if you're wondering if that's Earth-directed, let's go to Lagrange point 1, the location of the SOHO spacecraft, to look at the LASCO C3. So here's the LASCO C3, and you may or may not be able to see. First of all, note the date stamps. We're going back to 9/7 here. That coronal mass ejection occurred first thing in the morning on 9/8. And you can see plasma on all sides of the coronagraph here, an indication that it's Earth-directed. A little bit of it is more westerly than Earth-directed, but some portion of it is certainly Earth-directed. We can expect the arrival of that around 9/11. We're not expecting anything major, maybe a geomagnetic unrest period briefly, depending on the rest of the solar wind regime. Although I don't think there are any major coronal hole wind streams on the way either, so it may show up as a significant signal there, especially if we see a real weak solar wind when this arrives on the 11th. So here is the colorized magnetogram. This is the last day and a half or so. This is all day yesterday and the day to date today. Let's just zoom out so you can see the time and date stamps there down in the bottom left. And all of the major sunspots here remained largely consistent over the past 36 hours. And how about some more imagery? Here's 335 angstroms. And we've got some close-ups of the northern and southern hemisphere toward the end of the video. Let's blast through a whole lot more data. The radial flux has dropped down to 100 solar flux units. Still the highest levels we've seen since December of last year. So there you can see 100 solar flux units not achieved for about 10 months. So here's the Enlil spiral on the Space Weather Enthusiast dashboard. And the modeling of this looks like it's flawed once again. I don't know how they're being so far off with the trajectory, but you can see they're showing more of a glancing blow here. I don't know. They're also calling the strike not showing up until the 13th. I think it's going to be a little earlier than that. But in any case, that's the forecast from the Space Weather Enthusiast dashboard from NOAA. Here's the data we usually show. No geomagnetic unrest or space weather storms currently in the forecast. I would expect an uptick in geomagnetic activity late in the day on the 11th, based on my analysis and the modeling. Let's take a brief look at global seismicity. Here's the year to date in bar graph form, the convenient bar graph from volcanodiscovery.com. There's the last 90 days. And we have seen some significant quakes here over the past 24, including this South Sandwich Islands region remaining active. At least one deep quake in western South America there. Let's go up the list. One of the most desolate regions in the world saw a 4.6 southeast of Easter Island there. The area off the west coast of South America, highly uninhabited. There's a 5.6 near that other quake. Largest quake of the past 24 was, I believe, a 5.9. So a bit of activity there in the eastern Pacific off the west coast of South America as we see multiple quakes there. Also a very deep quake near Fiji around the same time of day. Almost exactly the same time of day. That was at 562 kilometers on a 4.3 magnitude. 5.6 there at the South Sandwich Islands region. A 5.8 near Tonga. That was at the surface, despite Tonga being one of the deep quake areas of the planet. And another very deep quake near Fiji as well, coming in just a couple of hours ago here. It's a 5.3 at Fiji. That one came in at 7:18 universal time. Let's look at volcanoes briefly as well. Iasca. Did you see our coverage yesterday about Aska, the Icelandic volcano? Well, Karimsky on the Kamchatka Peninsula is erupting. Uptick there at Kamchatka. It's a 22,000-foot ash plume. Subanose Jima exploding in the Ryukyu Islands south of the Kamchatka Peninsula. That's producing a flight level 090. It's a 9,000-foot ash plume. Merapi exploding on the Indonesian island of Central Java. 10,000-foot ash plume from Merapi. Semeru exploding, 13,000 foot over East Java, Indonesia. Samisa Pochnoi. Volcanic ash report not provided. Please don't fly your hang glider or John Denver-style ultralight aircraft over the Samisa Pochnoi volcano in the Aleutian Islands. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Sangay exploding, 19,000-foot ash plume over Ecuador. Revenador exploding, 15,000-foot ash plume over that same country of Ecuador. And Sabancaya producing intermittent emissions and explosive activity and a 22,000-foot ash plume. Please don't pull Volta Caldera. Please do visit our links and support the channel. If you visit the Redbubble shop, you can find links to that at smashamash.com. Smashamash.org will relocate you. Use the promo code SHOPTEMBER throughout the day today to save 20% on whatever you want. And our designs are quite spectacular. The print quality is ridiculous. So check it out, smashamash.com, the Smash merch link located there. Next, looking at the GOES magnetometer, and we're seeing pretty low highs and high lows, actually, in the GOES 16 and 17 magnetometer data there. Nothing to write home about. Earth is in a North Pole-oriented current sheet where it will remain for the foreseeable future. Here's the top view ecliptic plane field plot showing the magnetism of the current sheet. The solar polar fields orient the current sheet to one or the other pole. Earth is currently in a North Pole-oriented one, shown here in green. There's the latest image. And again, we expect to remain in the North Pole current sheet for the foreseeable future. Here's the line of sight ecliptic plane field plot, the same data from a more earthly perspective here. Great three-dimensional imagery there of the heliospheric current sheet. And we see cycle 25 finally progressing a bit here. Here is the sun's B field shown in blue. It's also showing coronal holes in red or green. Coronal holes are associated with one or the other pole, folks. They tell us about the solar polar magnetism, the solar polar field reversals that occur during a sunspot cycle. That's why we show this daily. This is one of the most important data sets that we can view when analyzing the progression of a solar cycle. Anyway, there's the latest data. And you see a large transequatorial coronal hole here. It's not very wide, but it's quite long, stretching well down past the equator here of North Pole orientation. So here's the 193 angstroms imagery of that for the past day. And for you new viewers, 193 angstroms is ionized iron. And congratulations on realizing that our channel exists. Please tell your friends and foes about us. Here's our solar flare monitor. Let me make that a little bit more square, as the sun is not that elliptically shaped, folks. Anyway, 6 sunspot groups, likelihood of major solar flares quite high. And as these regions here, known as 3 and 4 here on those regions right there that are right in the Earth-facing zone, the likelihood of those producing major flares goes up as they approach the western limb. Yes, it's called the Earth-facing quiet, and it's looking more and more like Robitaille has been correct the whole time. Next, looking at photons. And once again, we saw a flare happening while we did show prep. So this one happened right before yesterday's live stream. This one was the only C-class flare that happened all day that day. And that happened right when we did our video. So yeah, solar flares here coinciding with our channel repeatedly. Once again, just subsiding here while we did show prep. Is it a coincidence? Leave us a comment. Let us know. If you've got a comment directly for the sun, leave that in our comment section as well. Here's the proton flux over the past 3 days. No spikes in that. No relativistic particles headed Earth's way. Let's look at the real-time solar wind next. And here's that. We do see some error bars here. These yellow lines down here, those are suspected errors in the solar wind. Some little weird variations. By the way, my forecast yesterday for the coronal hole wind stream was pretty close. I guessed it may reach up to about 450. It only made it to 440. I think that's a pretty good guess. And we see that largely subsiding here. Current solar wind 422 kilometers per second. Solar wind density 4.08 protons per cubic centimeter. The rest of the panes here are fairly unremarkable. Next, looking at magnetohydrodynamic pressure over the past 4 hours, and it's pretty homogeneous. No surprises there. No major changes to the solar wind regime. It's a waning high-speed coronal hole wind stream. And the pressure is probably going to mildly reduce here throughout the 4 hours of magnetosphere movie shown. We show it daily to give people an idea of what's going on in the geospace. Next, ground magnetic perturbations, geospace delta B, changes to Earth's B field. And since we're living a polar excursion, we show this daily. Did you know that the South Magnetic Pole has left the Antarctic continent and is someplace down here south of Australia? Yeah. Did you know the geomagnetic pole is actually moving toward the geographic pole? And that the geomagnetic pole is the magnetic moment from space, and the magnetic pole is the magnetic pole on the surface? We do see some pulses here coming out of the Indian Ocean, around the Bay of Bengal, the Philippines. They're pretty minor. And like the last frame, that's 4 hours of data. It's modeled on the space weather modeling framework. So the KP index is a measurement of global geomagnetism. And we saw 2 brief periods of geomagnetic unrest yesterday. Now back to calm conditions. It's a KP of 2. Here's what's going on in the solar system. We'll advance this 1 week. And there's where things will be on the 16th of smAshtember. And shout out to the Smash team. This video was brought to you in part by the Smash team at smashomash.com/SmashTeam. Here's a star chart. It's from in-the-sky.org. I face mine to the south. I'm currently facing the south. Also, my sofa faces the south. And the foot of my bed faces the east. Did you know? Anyway, we've drawn in the ecliptic plane and the galactic plane here on our star chart. If you want to build your own, just head to that website, put in your location, and you can do it. Today's Cosmology 7 is going to be brief. I've gone out on a limb and picked a random number here. It's 306, which is MRK 110, a Seyfert 2 galaxy, a type of active galactic nucleus, and this one's got a bit of an irregular shape to it. Let's take a quick look. Here it is in Pan-STARRS multi-band optical, and you can see this interesting, jet-like structure with this weird bend in it. Pretty odd galaxy. It looks like it could be a double nucleus, which perhaps explains why it's so irregularly shaped. Let's take a look at it in some different wavelengths here. Here it is on the 2 mass. That's infrared light, or you could say thermal emissions. And coming up to UV, here's the ultraviolet Galix survey. Very scant evidence of any irregular structures there. And let's take a look at it in false color X-ray. There it is in false color X-ray, a rather limited survey of its X-ray. And it's probably not very bright in gamma. Let's go back to pan-stars to close out this section of the cosmology segment. We'll zoom in on the very high resolution pan-star survey. And there is MRK 110. There are the X-ray transient outputs from MRK 110. It's pretty consistent over the past 16 years. There are the optical emissions from it. Perhaps a double nucleus, Seyfert 2 active galactic nucleus. And let's go to the astronomy picture of the day. Check it out. It's the Eagle Nebula, very famous in Hubble Space Telescope photographing history. One of the most spectacular nebulae and images of it from the Hubble Space Telescope here. Just a spectacular image for your computer desktop or perhaps your mobile phone. It's apod.nasa.gov's picture of the day, astronomy picture of the day, apod.nasa.gov. I've saved this one to my hard drive, and it's certainly worth having a look. The Eagle Nebula, otherwise known as Messier 16, number 16 in the Messier catalog. Just splentacular. And that's today's cosmology segment. We kept it brief. We integrated it into the daily space weather video. Check our other cosmology segments on our playlists. YouTube.com/smashamash/playlists. We see some minor charging hazards here on surfaces of satellites, mainly around Mexico, Central America, and moving into the Central Pacific Ocean. And we see some very chaotic electron belts. We'll get to it in a minute. Here's the 1-year chart from Solon.info. Here's the 3-day chart from the GOES 16 and GOES 17 data. And we actually see low levels of electron flux here coming out of warning levels. We never got back into warning levels yesterday, but we see some chaos happening up there. So here's the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of Earth Van Allen belts, and here's the total electron content forecast. And we see very high levels of electron flux over Southeast Asia. So look at these red blobs forming here right at the beginning. We'll let it play through a second time. You're going to see red blobs in this area. Those are very high levels of electron flux in very specific areas. So this is showing the entire electron density throughout the air column up to your geosynchronous satellite. It's very effective at predicting GPS errors. So a little bit of chaos there. Not high levels of overall electron flux, but high zonal areas. Next, the diagram of the atmosphere, because we're going to show you the F ionosphere next. In our ionograms, we show them daily. Here's the ionogram courtesy of Australian Government Bureau Meteorology, and we see some high-frequency anomalies here over places like South America. They're pretty minor, but as we approach an equinox, we'll see more and more ionospheric anomalies because, well, equinoxes are more geomagnetically active than times around the solstices. It all has to do with the angle of the Earth's axis with respect to the sun. So there's your ionogram. Here's the latest image. That's 9:30 Universal Time. Here's your anomaly map. This is departure from the 30-day median in megahertz. Blue is showing you high-frequency anomalies. Red is showing you low-frequency anomalies. And we see some low-frequency anomalies around Hawaii, actually. But mostly high-frequency anomalies. Here's the latest image from 9:30. Things looking normal at that moment, 9:30 Universal Time. Meteorology is pretty sweet. We take it seriously here at the Smash News Network, least busted name of news, as well as bonus features. So here they come. It's the latest from the El Teide, Spain, ground-based solar observatory. We want to give you all kinds of different data here so that you're confident in that what you're looking at is not nonsense. As if Since this video appears on YouTube, it is side by side with a lot of nonsense. A lot of nonsense and grifters on YouTube. Anyway, here's the latest data from El Teide, Spain. Again, 6 sunspot groups, coronal mass ejection warning in effect, coronal mass ejection warning in effect, solar flare warning also in effect. We're more likely to see large solar flares than not. So here's the latest refresh. Large sunspot up there. It's still beta class. We still do see some trailing opposite polarity umbrae. Here's this southwesterly one. That is now barely beta class, maybe becoming alpha class. These two here, especially this one, very complex magnetic structures, very likely to produce M-class flares or possibly even X-class flares. This one down here at a very very high polar latitude. You can see how much farther south that is. And here's this new spot rising here. This one looks alpha class at the moment. And here's the latest refresh of the of the colorized magnetogram. Again, that looks like it's alpha class. The rest of these are quite complex, especially this one. But all 3 of those are quite capable of producing large flares. The rest a little bit less so. Here come the rest of our bonus features. It's the full disk view in 304 angstroms ionized helium from the SDO. Just spectacular imagery here from the Solar Dynamics Observatory. So there are massive filaments here. There's a massive filament up here and a massive filament down here, which I've named Cerberus, after the 3-headed dog that guards the gate to the underworld in Greek mythology. The giant 3-headed demon dog. It's Cerberus, the filament. Here's the northern hemisphere in 335 angstroms. Great Earth scale there showing you how large that northwesterly sunspot and the associated plage is. It's a large plage, not to be confused with large marge. Here's the southern hemisphere in the same wavelength. 335 is ultraviolet light emissions from ionized iron. And you can see that nearly M-class flare there right at the beginning of the video. And that one happened just about a half an hour before we went live. By the way, we go live every Wednesday at 2 p.m. It's our weekly Wednesday live stream, YouTube exclusive. If you didn't check that out, check it out. It was a pretty good one yesterday. I liked it. We talked about lots of space stuff, which we don't necessarily always do. And here's another full disk view. This is 304 and 171 angstroms. Could be my favorite composite, but really which composite that we view depends on what the activity is. So this one is great at showing filaments as well as magnetic loops. That's the 171. The filaments are 304 angstroms ionized helium. And it's about time to get this video uploaded. So thanks everybody for tuning in. Again, don't forget to press like and subscribe. Tell your friends and foes about us. We're blowing up and we're going straight to space. I mean physically. So may that solar wind be at your back.